Page 81.
Part 3.
4.11 Triangles. A triangle is a three-sided polygon. In fact, it is the polygon with the least number of sides. Look at the triangle in the diagram, figure 4.21. We write triangle sign ABC instead of writing triangle ABC. In triangle ABC, how many sides and how many angles are there? The three sides of the triangle are AB, BC, and CA. The three angles are angle BAC, angle BCA, and angle ABC. The points A, B, and C are called the vertices of the triangle. Being a polygon, a triangle has an exterior and an interior. In the figure 4.22, P is in the interior of the triangle, R is in the exterior, and Q on the triangle. Exercise 4.4. 1. Draw a rough sketch of a triangle ABC. Mark a point P in its interior and a point Q in its exterior. Is the point A in its exterior or in its interior? 2. A. Identify three triangles in the figure. B. Write the names of 7 angles. C. Write the name of 6 line segments. D. Which two triangles have angle B as common? (4.12) Quadrilaterals. A four-sided polygon is a quadrilateral. It has 4 sides and 4 angles. As in the case of a triangle, you can visualize its interior too. Note the cyclic manner in which the vertices are named. This quadrilateral ABCD, given in figure 4.23, has 4 sides: AB, BC, CD, and DA. It has 4 angles: angle A, angle B, angle C, and angle D. Page 82. We have 2 figures here. This is quadrilateral PQRS. Is this quadrilateral PQRS? In any quadrilateral ABCD, AB and BC are adjacent sides. Can you write other pairs of adjacent sides? AB and DC are opposite sides. Name the other pair of opposite sides. Angle A and angle C are said to be opposite angles. Similarly, angle D and angle B are opposite angles. Naturally, angle A and angle B are adjacent angles. You can now list other pairs of adjacent angles. Exercise 4.5. 1. Draw a rough sketch of a quadrilateral PQRS. Draw its diagonals. Name them. Is the meeting point of the diagonals in the interior or exterior of the quadrilateral? Two. Draw a rough sketch of a quadrilateral KLMN. State A. Two pairs of opposite sides. B. Two pairs of opposite angles. C. Two pairs of adjacent sides. D. Two pairs of adjacent angles. 3. Investigate. Use strips and fasteners to make a triangle and a quadrilateral. Try to push inward at any one vertex of the triangle. Do the same to the quadrilateral. Is the triangle distorted? Is the quadrilateral distorted? Is the triangle rigid? Why is it that structures like electric towers make use of triangular shapes and not quadrilaterals? Page 83. 4.13. Circles. In our environment, you find many things that are round. A wheel, a bangle, a coin, etc. We use the round shape in many ways. It is easier to roll a heavy steel tube than to drag it. A circle is a simple closed curve which is not a polygon. It has some very special properties. Do this. Place a bangle or any round shape. Trace around to get a circular shape. If you want to make a circular garden, how will you proceed? Take 2 sticks and a piece of rope. Drive 1 stick into the ground. This is the center of the proposed circle. Form 2 loops, one at each end of the rope. Place 1 loop around the stick at the center. Put the other around the other stick. Keep the sticks vertical to the ground. Keep the rope taut all the time and trace the path. You get a circle. Naturally, every point on the circle is at equal distance from the center. Parts of a circle. Here is a circle with center C. Figure 4.24. A, P, B, M are points on the circle. You will see that CA is equal to CP is equal to CB is equal to CM. Each of the segments CA, CP, CB, CM is radius of the circle. The radius is a line segment that connects the center to a point on the circle. CP and CM are radii, which is plural of radius, such that C, P, M are in a line. PM is known as diameter of the circle. Is a diameter double the size of a radius? Yes. PB is a chord connecting 2 points on a circle. Is PM also a chord? An arc is a portion of circle. If P and Q are 2 points, you get the arc PQ. We write it as PQ with an overhead sign of the arc. Figure 4.25. As in the case of any simple closed curve, you can think of the interior and exterior of a circle. A region in the interior of a circle enclosed by an arc on one side and a pair of radii on the other 2 sides is called a sector. Figure 4.26. Page 84. A region in the interior of a circle enclosed by a chord and an arc is called a segment of the circle. Figure 4.26 given here shows a sector and a segment of the circle. Take any circular object. Use a thread and wrap it around the object once. The length of the thread is the distance covered to travel around the object once. What does this length denote? The distance around a circle is its circumference. Do this. Take a circular sheet. Fold it into two halves. Crease the fold and open up. Do you find the circular region is halved by the diameter? A diameter of a circle divides it into two equal parts. Each part is a semicircle. A semicircle is half of a circle, with the end points of diameter as part of the boundary. Exercise 4.6. 1. From the figure, identify A. The center of circle. B. 3 radii. C. A diameter. D. A chord. E. 2 points in the interior. F. A point in the exterior. G. A sector. H. A segment. Two. A. Is every diameter of a circle also a chord? B. Is every chord of a circle also a diameter? 3. Draw any circle and mark A. Its center. B. A radius. C. A diameter. D. A sector. E. A segment. F. A point in its interior. G. A point in its exterior. H. An arc. 4. Say true or false. A. 2 diameters of a circle will necessarily intersect. B. The center of a circle is always in its interior. What have we discussed? 1. A point determines a location. It is usually denoted by a capital letter. 2. A line segment corresponds to the shortest distance between 2 points. The line segment joining points A and B is denoted by A, B and an overhead line segment symbol, a dash. Page 85. 3. A line is obtained when a line segment like AB is extended on both sides indefinitely. It is denoted by AB with an overhead symbol of line with 2 arrows in both directions, or sometimes by a single small letter like L. 4. 2 distinct lines meeting at a point are called intersecting lines. 5. 2 lines in a plane are said to be parallel if they do not meet. 6. A ray is a portion of line starting at a point and going in one direction endlessly. 7. Any drawing, straight or non-straight, done without lifting the pencil may be called a curve. In this sense, a line is also a curve. 8. A simple curve is one that does not cross itself. 9. A curve is said to be closed if its ends are joined, otherwise it is said to be open. 10. A polygon is a simple closed curve made up of line segments. Here, 1. The line segments are the sides of the polygon. 2. Any 2 sides with a common end point are adjacent sides. 3. The meeting point of a pair of sides is called a vertex. 4. The end points of the same side are adjacent vertices. 5. The join of any 2 non-adjacent vertices is a diagonal. 11. An angle is made up of 2 rays starting from a common starting or initial point. 2 rays OA and OB make angle AOB, or also called angle BOA. An angle leads to 3 divisions of a region: on the angle, the interior of the angle, and the exterior of the angle. A triangle is a 3-sided polygon. 13. A quadrilateral is a 4-sided polygon. It should be named cyclically. 'In any quadrilateral ABCD, AB and DC and AD and BC are pairs of opposite sides. Angle A and angle C and angle B and angle D are pairs of opposite angles. Angle A is adjacent to angle B and angle D. Similar relations exist for other 3 angles. 14. A circle is the path of a point moving at the same distance from a fixed point. The fixed point is the center. The fixed distance is the radius, and the distance around the circle is the circumference. A chord of a circle is a line segment joining any 2 points on the circle. A diameter is a chord passing through the center of the circle. A sector is the region in the interior of a circle enclosed by an arc on one side and a pair of radii on the other 2 sides. A segment of a circle is a region in the interior of the circle enclosed by an arc and a chord. The diameter of a circle divides it into 2 semicircles.